Problem 3 asks us to evaluate the limit as x goes to 6 of this expression. So if I try to plug 6 in the numerator, I'm going to get 0. And if I plug 6 in the denominator, I'm going to get 0. So this is definitely a L'Hopital situation. So this is a problem we could do with algebra. We could factor the numerator and hopefully the x minus 6 would cancel, and then we could evaluate the limit. And you should get the exact same answer if we apply L'Hopital. So if we do L'Hopital, we say, well, then this is the limit as x approaches 6. The derivative of the numerator is 2x minus 7, and the derivative of the denominator is 1. So now if I plug in 6, I get 12 minus 7 is 5. So for functions that are really easy to differentiate, like polynomials, this might be a quicker method to get to the answer than doing algebra. Number 4, we see we're looking at the limit as x goes to infinity of an exponential over a cubic. So this is an infinity over infinity situation. So I'm going to do L'Hopital's. And the derivative of the numerator is e to the 2x, right, times the derivative of 2x. So it's just 2e to the 2x. The derivative of the denominator is 15x squared. So now if I check it again, I'm still at infinity over infinity. And you can kind of see what's happening. E to the x is going to stay e to the x. But the denominator is going to reduce in power every time I take the derivative. So if I do it again, it's going to drop down to x. And if I do it again, it's going to drop down to 15. But this e to the x is always going to be here. So I can kind of already see that this limit is going to end up being positive infinity. But let's watch this play out. This is an example of where we can do L'Hopital over multiple iterations. So because I'm still at infinity over infinity, now I'm going to take the derivative again. So it's e to the 2x times another 2. So I get 4e to the 2x. 2 times 15 is 30. So I have 30x. So I'm still at infinity over infinity. So I can do this again. And now I'm going to get 8e to the 2x over 30. So when I plug in infinity here, this is in fact going to be positive infinity. So this limit, right, the y values, they're increasing with outbound. This also demonstrates why, if we look at a function like this, we can see that exponentials outpace polynomials. So this guy's getting to infinity much faster than this guy's getting to infinity. And you can see we did 1, 2, 3 derivatives before it was crystal clear. But that's how you would take this problem all the way out to its conclusion.